hello everyone. Today we are going to see about the non-linear equation of second order problem, that is nothing but Monge's method. So for that Monge's method, we need to consider the equation that is r plus s plus t plus u of rt minus s square equal to v. In this equation, there are two cases, that is if u not equal to 0 means we contain one form of solving and to get the solution, and the second one case to is u equal to 0 means we have to solve in another method. So for the case 1, that is u not equal to 0 means we have to find the roots of the roots in the form of quadratic equation, that is lambda square into rt plus uv plus lambda us plus u square equal to 0, and we have to solve the equations in two pairs. So u dy plus lambda 1 t dx plus lambda 1 u dp equal to 0, and lambda 2 r dy plus u dx plus lambda 2 u dq equal to 0. This is the one pair, and u dy plus lambda 2 t dx plus lambda 2 u dp equal to 0, and lambda 1 r dy plus u dx plus lambda 1 u dq equal to 0. This is the another pair. So this is after solving this, we have to form in the form of dz equal to p dx plus q dy. We have to find the z values. So this non-linear equation, this is the formula for solving steps to solve the non-linear method. The derivation contains a lot of terms. The derivation involves lot of terms, and we finalize these steps to solve the Monge's method if u not equal to 0. So the example is example 13, that is r plus 4r plus t plus rt minus s square equal to 2. So we have to compare the equation, that is r plus s plus tt plus u of rt minus s square equal to v. So we easily find the values equal to 1, so it is in the first case. Then we have to compare this equation. This r is nothing but 1, and the capital S is nothing but 4, and the capital T is nothing but 1, and we know that u is 1 and v is after the equal value, that is 2. So now we get all the values. So we now have to form the quadratic equation, that is in the form of lambda square rt plus uv plus lambda uv plus u square equal to 0. So while we substituting the values of r, t, u, v, we get lambda square into r value is nothing but 1, t value is 1, so 1 into 1 1, plus u value is 1 and v value is 2. So 2 plus lambda into u value 1 and s value 4 plus u square is nothing but 1 equal to 0. So if we solve means 3 lambda square plus 4 lambda plus 1 equal to 0. We have to find the factor. So lambda plus 3v. So if we take the lambda common means we get 3 lambda plus 1 here. If 1 common means 3 lambda plus 1 equal to 0, and taking 3 lambda plus 1 as common means we get lambda plus 1. So next we have to find the lambda 1 and lambda 2 values. So lambda 1 equal to minus 1 by 3 and lambda 2 equal to minus 1. So we find the lambda 1 and lambda 2 values in the form in the form of quadratic equations. So we have to substitute the lambda 1 and lambda 2 values. U dy plus first pair we have to substitute the lambda 1 lambda 2 values. U dy plus lambda 1 t dx plus lambda 1 u dp equal to 0, and lambda 2 r dy plus u dx plus lambda 2 u dq equal to 0. So u value is nothing but 1, dy minus lambda 1 is minus 1 by 3 dx, minus t value is 1, lambda t value is 1 and lambda value is minus 1 by 3, so minus 1 by 3 dx, lambda 1 value is minus 1 by 3, u value is 1, so dp equal to 0, and if we multiply the 3 means we get 3 dy minus dx minus dp equal to 0. And next time if we take the minus, it's our wish to take, because it is if we take the minus means the equation becomes so simple and easy to eliminate. So minus dy. So this is in the form of next pair. So next pair of equation, that is lambda 2 r dy. So lambda 2 value is minus, dy is as it is, r value is 1 plus u value is 1 dx minus dq equal to 0. So if we take the minus common, means we get dy minus dx plus dq equal to 0. This is for our simplification, we are taking the minus here. From 9 we get the value, that is, if we integrate, means we get 3y minus x minus p equal to c1, because while why we are integrating, means we have to find the p value and q value. So that for that only we need to why we find the p and q values, we have to substitute in this equation. So for that only we are integrating the terms. If we integrate, means only we get the p values. So 3y minus x minus p equal to c1, and if we integrate, this means y minus x plus q equal to c2. So the 11th equation will become as 3y minus x minus p equal to c1. We consider we consider only f of c2. So our c2's value is nothing but y minus x plus q. So then what we are doing, means we have to solve the second part, that is formula. If we substitute the value, means we get minus 1 by 3 dy plus dx, sorry, dy minus dx minus dp equal to 0. The second part, if we substitute, means we get minus 1 by 3 dy plus dx minus 1 by 3 dq equal to 0. If we multiply the 3 on both sides, means we get dy minus 3 dx plus dq equal to 0, and our 14th equation will become, if we integrate, means we get y minus x minus p equal to c3, and 15th equation will become as y minus 3x plus q equal to c4, and in previous term we consider c1 as f of c2, and in this term we consider c4 as a g of c3. If we consider, means we get the value of y minus 3x plus q equal to g of our c3 is values y minus x minus p, and in this form, from 17 we get the form of q. So we have to, basically we have to find the value of q and p. So q value will become a c4 plus 3x minus y. This is our q value, and if we substitute the q value in the 13th equation, means in this equation, means we get 3y minus x minus p equal to f of y minus x plus q. This is the 13th equation. If we substitute the q value, means we get c4 plus 3x minus y, that y getting cancelled, and the balance terms are 2x plus c4. Then we, in this form, we can find the p value. So p equal to 3y minus x plus f of 2x plus c4. So this is in the form of p. This is in the form of p. So we have to substitute, we have to find the next term, that is dz equal to p dx plus q dy, and p value is nothing but this one. So it involves only a function that is contain the constant terms and x and y terms. So 3y minus x plus f of 2x plus c4 dx plus and q value c4 plus 3x minus y dx. So if we differentiate with respect to, if we multiply the dx in this term, means we get this, and our dz will be 3 d of x comma y minus x dx minus y dy plus f of 2x plus c4 dx plus c4 dy. So if we have to find the z value, so z value will become, if we integrate, means we get z equal to that 3xy minus, they are having minus x dx, so it will become minus x square by 2 minus y square by 2, and if we integrate the function, means we get another function that will be represented as capital F. So f 2x plus c4 plus, if we integrate c4 dy, means we get c4y plus the constant term. So we have two arbitrary constant in the solution, that is c4 and c5. So it has a complete integral. Hope you all understand, and thank you.